Hello guys, welcome back to my YouTube channel. So if you haven't watched the previous videos regarding this series and the shunt, please do so, as today I want to talk about the compound motors. So as I mentioned on the previous video, that the compound motors, it is the combination of series and shunt, whereby I say the word shunt means parallel. So on the compound motor, you can have two types of compound motors. You can have what we call the differential compound motor. You can also have the cumulatively compound motor, and on your calculation, you can either have the short shunt compound motor connection, and then you can also have the long shunt compound motor connection. So the first diagram that I have here, it's a long shunt compound motor. So it is called long because now you are having these field resistance connected in parallel with a combination of these two, whereby you have the series and the armature. So these two, they're in parallel with these. So the first thing, your formula to calculate your I shunt is not affected. Remember on the previous video, we said to calculate I shunt, it will be V divided by R shunt. All right, okay. And then the other thing that you should know, since your series resistance and the armature, they're in series, so your I series, it will be equals to IA, meaning the current, it is the same. And then how do I calculate my EMF now? It will be V minus IA. So open bracket. Now you're having two things there to be RA plus R series. And remember, I said if you are given the brush voltage or the brush resistance, you also have to include that. Okay. So these are the calculation which you have to do with the long shunt compound, or you can also have the one for power, which is VI. Okay. And you can also have the short shunt. So this one it's called a short shunt now because only these two, they are in parallel, not the whole circuit, it's in parallel. So only these two, they are in parallel. The other thing that we can notice, your IL and I series is same. Hence we can say IL and I series, they are the same. All right, okay. So your circuit, the entire circuit is no longer a shunt circuit, or this part is not in parallel with this part. Hence, the voltage now, I cannot use the same voltage to calculate I shunt. So for me to calculate I shunt, I have to use the specific voltage of a parallel circuit, which is this part, which is going to be V shunt divided by R shunt. So that's how you calculate your shunt current. If you want to calculate your V total, remember, if I add this voltage and this voltage, they're supposed to give me the supply voltage. So hence we can say V series plus V shunt. So to calculate my VT, it will be V series plus V shunt. All right, okay. So these are some of the formulas that you can use. Okay, and then let's also check with our current. So remember here you have A, so you have I series coming in, hence I can say I series is equals to I shunt plus IA, and your formula to calculate your EMF, it will be E minus, so you can also use the one which says IARA, and then minus I series R series. And I said is you're given the brush, you can also include the brush resistance and the brush voltage. Okay, and then you also have this formula to calculate the motor constant, which is 2P Z divided by 60C, of which I've already explained on the previous video, or what is P, what is Z, and what is also C. And this one that you can use to calculate your speed, which is rev per minute, which is going to be E divided by the motor constant multiplied by the flux. All right, okay, so let's look on a question from a textbook. So they're saying 10 kilowatts, 440 volts short shunt compound wood DC motor operates at a full load efficiency of 85. So let's just draw our circuit. So this is our circuit. Okay, so from the supply, they're saying you're given a power, which is 10 kilowatts. Okay, you are given the voltage, which is 440 volts. They're saying operating at a certain efficiency. Remember, I said whenever you're given a power and the efficiency, the power that you're given becomes an output power. So it's operating at 85%, and this becomes PO. Okay, they're saying a series field and a shunt resistance are. So you're given, okay, they're saying of 85%, he has a series field and a shunt field resistance. So the first one, the series field 0,3, and the shunt field R shunt, it's 140 ohms. All right, okay. They're saying calculate the following if the armature resistance, you're given the value of the armature, which is 0,1, 0,15, and the brush conductive voltage. So you're given V brush. Okay, let me write it again. Which is 4,2 volts. Okay, so this is our given information. So let me just try to push it to the side so we can calculate. So firstly, they want you to find the current drawn from the supply. So they want you to find IL. Okay, how do you find IL? Remember, you can use, we said IL is equals to P in divided by V. And remember, this is the input power, but here you are given the output power. So in order for me to find the input power, remember the formula of the efficiency is P out divided by P in multiplied by 100%. Okay, so here it will be P out divided by your efficiency, okay, which is the same as your P out, which is 10, okay, times 10 to the power 3, since it's in kilo, divided by 0,85. If I divide my 85% divided by 100, okay, and then we can have the input power, which is 11,765 kilowatts. Okay, so that's our input power. Hence, I can calculate my IA, which is going to be 11,765 times 10 to the power 3 divided by your input voltage, which is 440. Okay, and then you have 26,739 amps. So that's your A. Let's look on B. On B, they want the shunt field current. They want you to find the shunt field current. How do you find your shunt field current? Remember, we said to calculate your I shunt, it will be V shunt divided by R shunt. So in order for me to find my I shunt, I will need to find a V shunt. So let's see how can we find our V shunt here. Remember, we once had a formula. It says VT is equals to V series plus V shunt. Okay. So the other thing that we know, remember, we know that IL is equals to I series. So I can find V series. How do I find V series? It's going to be I series multiplied by R series. Okay. Which is same as 26,739 multiplied by R series, which is 0,3. Hence, you can find your V series, which is 8,022 volts. Hence, if I'm having that, I can find my V shunt by saying V shunt is equals to VT minus V series. Your VT you said is 440 minus 8,022, which would then give me 431,97978. So hence, if I'm having my V shunt, I can calculate my I shunt now by saying 431,978 divided by 140. Then hence I can find my shunt current, which is 3,086 amps. Hence I have my I shunt. And the next question, this was B. The next question on C, they want you to find the armature current. We said, how do you find the armature current? We said IA is equals to I series. So it will be I series minus I shunt, of which we have all of these values. Okay, our I series, it was 26,739 minus 3,086. Hence I can have my IA, which is going to be 23,653 amps. Okay, and then on the last part, they want you to find, which is D, they want you to find the back EMF. We said, how do you find the back EMF on this? We said it's V minus IA, RA minus I series, R series. And I said, if you're given the brush shift voltage, you can also include, which is say, it will be IA, R brush. But we're given as a voltage, so we just replace this with the voltage. Okay, so the same as 440 minus 23,653, and the shunt resistance multiplied by 0,15 minus I series says 26,739 multiplied by 0,3. Okay, and then minus the brush shift voltage we're given, which is 4,2. That's how you can calculate your EMF, which is going to be 424,23 volts. Okay, so that's how you can solve this question. Okay, so those are the calculations that you're supposed to know. So you can have a series, you can have a shunt, you can also have a compound, you can have a short shunt, you can also have the long shunt. And the other thing that you're supposed to know also, how to change the direction of these motors, how to change the direction of the motor. Okay, and you also have what you call the faceplate starters. Also know how to state the function of the faceplate motors and how do they operate and what is the application of these. So that's all from me. See you on another video.